sun's out again on the warmest day of the year so far. It's just beautiful to be off school, but I'm hoping to be back as soon as possible. So now we're going to look at the third page of the assignment of naming and drawing diagrams of the hydrocarbons. And this one has two sections, as you've probably noticed. I'll leave the cyclic hydrocarbons till another video, but now I'll have a look at mostly the alkynes, but there's one question about alkenes that turns up in the second column that we'll look at. So it's the third page of the assignment, but only the first part of that. There'll be another video about the cyclic molecules. So the first thing we notice is that these triple bonds, they go straight. And let's have a look why that is. If we have ethine here, which is just C2H2, then we get a triple bond in the middle, and then we don't have that 109-degree angle anymore. We have a straight molecule, simply because these three bonds are bunched up in the middle. These will, I suppose, repel equally, and we see them therefore on each end of the molecule. There's nothing to hold them at another angle. So it's straight. And that gives us this difficult looking thing where we get this equivalent sign in amongst all of the straight lines. So let's have a look at what we'll call that. So as usual, the first thing we have to do is decide where the longest chain of carbon atoms is. And let's see, we'll start 1, 2, because that's another one there, 3, 4, 5, 6. And I am going to start from this end because when we're naming alkynes or alkenes, we want the smallest possible number for where the triple or double bond is. So it goes 1, 2, 3, 4, 5, 6. Ugly, hey? So it's a hexyne. And here the triple bond starts on the lowest number, remember, hex 2-yne, and you might see it also written as 2-hexyne, and we're going to stick to that nomenclature for what we're doing, although don't be surprised to see that it's not very much different. So we've got hex 2-yne, and all we've got to do is take into account this, a methyl group, and this, another methyl group, both coming off the fourth carbon in the chain. And so it's 4,4-dimethyl hex 2-yne, or 4,4-dimethyl 2-hexyne, if you want to call it that. And you'd have a dash in front of the 2 there. Now let's have a look at this one, which looks quite frightening if you haven't done alkynes before. And so we have a look at where the longest line of carbons is, and it goes 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 1, 2, 3, 4, 5. We start from this end. These are both potentially methyl groups. It doesn't matter where we start, so I'll start there. 9. And this therefore is an ethyl group, and this is a methyl group. So let's name this babe. Let's have a look. It is 9, so it's nonine, and it's the smaller number here on either end of the triple bond, non-4-yne, or in the other kind of nomenclature, 4-nonine. And then we have to put the functional groups in, the alkyl groups, and we've got a methyl group attached to 2, so 2-methyl, and we've got an ethyl group attached to the 6th carbon, so 6-ethyl. 2-methyl, 6-ethyl, non-4-yne. A hideously complex looking molecule and a hideously complex name, but there we go. The next thing I'd like to do is have a look at two of the names in the second column that, well, nobody's sent anything into me about this yet because it's still Friday the 20th when I'm making this video, but I'm sure that some of you will have some fun with this. I'll just move that because my board appears not to be visible for a while there. So let's have a look at number 19, which is 3,4,6 triethyl 5,7 dimethyl, oh my, 1 nonine. And you'll notice the person who wrote this sheet, because of course I stole it and I didn't write it myself, because doing those structural formulae is like hideously complex on a computer, I would call it non-one-ine. So here I start, and normally I would be going 1, 2, 3, 4, 5, 6, 7, 8, 9. But I can't do that because the ine, the triple bond, is going to make a straight line. And here it is. So I actually have to make that like that, because the triple bond means that there will be a straight part of the molecule. So here's my non-one-ine. I forgot to write that before. And let's now label my, my carbons. Now, with non-one-ine, of course, we labelled it with the smallest possible number to show the position of the triple bond, and so we do that. There's no mystery there. And now all we have to do is put the functional groups, all the alkyl groups in there. So 3, 4, 6 triethyl. 3, 4, 6 triethyl, and 5, 7 dimethyl. And there it is. Looks like a drunken spider, but you can see what it is. And there's one more I want to do, because the writer of this worksheet decided they'd recycle another alkene problem. So here we go. Trans 2, 2, 4 trimethyl 5 propyl, and it goes on 3 octene. And straight away what I'd call that is oct3ene. That's already there. So we've got a double bond in there somewhere. The longest carbon chain is 8 because of the oct, and then we've got a bunch of alkyl groups to put in there, 3 methyls and a propyl for a change. So let's draw it. Oct first. 1, 2, 3, 4, 5, 6, 7, 8. Pretty easy. Then we'll have a look at 3 octene. It doesn't matter which way we do it, so for a change, I'll count from the left. And I'll do my double bond starting from 3. So that goes between 3 and 4, the lowest number indicated by the number on the name of it here. And so that's my oct3ene. Now I have to do all of the other stuff. And straight away, oh, you can see I've made a gamble. I forgot about the trans. So, is this a cis or is it a trans that I've drawn? Remember, a cis would look like this. And then it would go the same direction as the one there. So I have drawn it correctly as a trans. I'll draw a cis one in a while, as if it would be a cis, because I've messed that up a little bit. But let's try 2, 2, 4 trimethyl. Here's 2, 2, 4. There's my methyl groups, and on 5 we need a propyl. 1, 2, 3. And that's my answer. That's my trans molecule. But if I were just to change this to a cis shape, because I know that's still worrying a few of you, if I were to do cis 2, 2, 4 trimethyl, was it 5 propyl? Oct3ene. Then I'm going to do it differently. I'm going to go 1, 2, 3, and then I'm going to do my double bond here. And immediately I see I'm going to have to circle back on myself, so I'm going to draw it differently. So I'm going to draw it this way. 1, 2, 3, and now oh, that's from here, isn't it? So there goes There goes my double bond. And I've got my angles really bad. I've got them as a 90 degree, so let's spread them out a bit. That's better. And here's my 3. And now, because this one is a cis, it doesn't go down there to make a straight line, to make my usual wavy line that I was looking at with the alkanes, and I have to whiz it back to there. So it's 1, 2, 3, 4, 5, and now it goes the normal one. 6, 7, 8. So there's my cis molecule, which isn't on the sheet, remember? It's just an illustration. So that's cis oct 3-ene, and now I have to do 2, 2, 4, trimethyl, and 5, this is going to be messy, 1, 2, 3, propyl. So it follows the same rules, you just have to be careful with the enes that the cis and the trans are a little bit different. With alkynes, you don't get that decision to make because an alkyne simply makes a straight line where the triple bond is. Okay, back for more cycloalkanes and cycloalkenes shortly. Bye-bye.